Hello, everyone. Welcome to Shumla's Lunch and Learn program. It's really wonderful to see all of you on the screen today. I really enjoy this when we're far away from each other, getting to see people I haven't seen in a while. There are some of you I don't know, so for those of you who don't know much about me, I'm a chemistry researcher and I focus on radiocarbon dating of rock art. So that's what we're going to do today, is talk about how old Lower Pecos art is. And I also do some pigment analysis. I've had a long history of collaboration with Shumla for the past 10 years in my previous life as a college professor. But I've been the science director at Shumla now for about 4.5 years. So it seems like it was just yesterday and it seems like it's been forever. So it's really great. So I have my laboratory here and I work and collaborate with Shumla's team. And I work on dating rock art here in the Lower Pecos, but I also study rock art all over the world, and I'm fortunate to get to do that. But we're going to talk about Texas Lower Pecos rock art today. And I'm going to give a spoiler alert and answer my title question right now. How old is Lower Pecos rock art? And I'm going to do that in my first 4 or so slides. And then we're going to talk about how we know that, how we know the age of the rock art. So if y'all have questions, by the way, if it's really something that pertains to the slide I'm talking about, like just go ahead and unmute yourself and ask. But if you want to just type in your question into the chat, want to wait till the end, that's fine too. So there are 4 kind of defined styles of art in the region. And, sometimes we know how old something is because of what's depicted in the art. So the historic style of art, there'll be a church or a person in Western clothing, or maybe a horse. And so we already know how old this art is without having to do any scientific dating because of what's depicted in the art. I do have one sample that I'm hoping to analyze in the next month, though, from this church at Vaquero. And the reason that that's so important is because it's a known age standard for me. So being able to analyze a sample that I already know the age of is a way to test our techniques and make sure that we're getting the right ages. There's another style called the red monochrome style in the region. And in this style, the bow and arrow is depicted. So we know that this style of art was depicted after 1000 AD because that's when the bow and arrow was introduced into the region. We don't have any direct scientific dates on this style, and that's probably something that we should do in the future. But we do know in general when this red monochrome style was depicted, and that was from about AD 1000 to 1500. So then before the bow and arrow, art that is older would have an addle or a spear thrower depicted. And so always these little red linear figures have, here you can kind of see, I don't have my big mouse on, but you can see in the drawing that there is an addle in the figure's hand. These figures are very miniature. They're, centimeters tall for the most part, though there are some that fall out that are a little bit larger. But these sort of stick figures are called the red linear style. And we really don't have any direct ages on this style either, though we do know from superimpositioning, so when you have paint layering, then we know that these are always underneath Pecos River styles. So when there's both styles present and they're found together, these always are painted underneath Pecos River styles. So the idea is that they would be at least contemporaneous or older than the Pecos River style, but we're hoping in the next couple of years to have some direct ages on this style. So that's going to be really, really exciting. And then there's the Pecos River style. This is what everybody knows about. This is the large polychromatic figures. This is from Halo Shelter, the paintings that I've got here. And we do have direct radiocarbon ages on this style. And we actually have 29 experimental legacy dates that place this style into the late and middle Archaic. These results were obtained by my former PhD advisor, Marvin Rowe, in the 1990s. And, but there's some problems with these dates, and that they have very large plus or minus error on them. So the range is, we know they fall in the late Archaic, but on every single date, it's like plus or minus 300-400 years. So we have very large error ranges. And there is some problems also with some contamination. And so I recently went through all that old data, and we kind of determined that with the improvements over time with the technique, we think we can get higher resolution dates that don't have as big a plus or minus. And so we're really excited because we're gonna start answering some new research questions. So y'all still hanging in there? Okay.
Yep.
Okay, good. So so within this last year, I've really been, shifting my focus on initiating this new radiocarbon dating campaign for the Lower Pecos. We still have a lot of gaps in our knowledge of how old Lower Pecos rock art is. I can say confidently, that it's from, 1,500 years to 4,000 years old, but that's a very large time range. And so what we want to be able to do is say, not just how old the art is in general, but we want to ask specific questions. Is the art from this one site the same age as the art from another site? And how do the styles of those art compare? Say, do all the figures with deer headdresses, do they have the same age? Or are they does that particular way of depicting a figure, does that last for 1,000 years? How long does it last? And so by taking all of the data that the Shumla archaeologists have collected on these figures, we'll be able to specifically sort of target figures that will give us the most information when we do that radiocarbon dating. And we're going to be able to get more precise data, smaller plus or minus error on our dates. We think we'll be able to get down to about plus or minus 70 years. And so that's really exciting. So how do we do all of this? Well, I work in a lab. Most of the time I'm in a laboratory. And, as Shumla Science Director, we work with the lab and we work with interns. So here are my two most recent interns here in the plasma oxidation lab. And I'm going to talk a lot about something called plasma oxidation today, which is something that we use to radiocarbon date rock art. And anyway, so let's see, I wrote down, let's see, in the past 4 years, and this is including the pandemic year, we've had 7 chemistry interns and 9 archaeology interns at Shumla. So student training is really a large part of what we do. Here is, on the left is Dr. Lori Barkwell Love. She was sort of a non-traditional intern in that she has her PhD in anthropology. And she wanted to know more about radiocarbon dating in the lab. And so here she is getting a new vacuum pump ready to put on the system. And then on the right, we have my current intern who started on Monday. So he's brand new. His name is Jesse Velasco. He's from Farmington, but he actually graduated from the University of Central Arkansas, which is where I used to teach. So go Bears. And he's doing a leak test on our new instrument here that we've built. So also, this is a bunch of high school students from the local high school. So as you can tell, I'm really into student education. But we teach a class at the local high school, and seniors from the school come up to the laboratory and work with me. And my goals are to teach them a little chemistry and a little bit of scientific research design. But my main goal is to have them gain an appreciation for this prehistoric rock art that's right here in Texas, right? You know, some of them have never seen rock art, even though they've lived here their whole life. And so to me, that's really important that they understand that they live in a very special place. This is last year's group, so that's why we're all just hanging out and chilling. But here, the guy with the cool hair, that's Rudy, who was also a college intern. And so, and then the rest of these are well, here's their teacher, Miss Timms, but then the rest of them are high school students. But I did do a class this year in the pandemic. It was different, if you know anyone who taught. But we did both Zoom and in person when we were able. But last year's group got to do something pretty cool in that they got to help me assemble a new plasma instrument. So these are on the table here on the right, little bitty pieces that come in different shapes. And then you can put those together kind of like Lego blocks, and you can build whatever scientific instrument you want. And this is vacuum equipment, because we don't want any contamination from the air when we're processing our samples. So we have to suck or vacuum out all the air. So this is all sort of airtight components. And here they are kind of getting it ready to be or it's all put together here on the left.
Hey Karen, how many samples can you do now?
10.
Wow.
Yeah, so Jade, who asked the question, she was an intern. Oh gosh, how many years? It's been what, 2 years ago, 3 years ago, Jade?
Yeah, 3 years ago. Yeah.
Time flies. I feel like the pandemic year doesn't count. So,
okay.
But anyways, when she was there, and I'll show a picture of the instrument that she worked with, we would analyze one sample at a time, and it would take us about 2 days to do that. And so now with this new instrument that we built, we can analyze 10 samples in the same time, about 2 days, you know, do other things and stuff. So it's great because I was sort of shackled, and Jade was too, shackled to that instrument, because it was like we always had to be doing something because we could only do one at a time. So with this instrument, we're able to do 10, and it is completely constructed now. And I have processed samples for about 5 weeks on it now. So I've done about 50 in 5 weeks. It's super exciting. And because I tend to kind of just run 2 days a week, and then I can, you know, write things and do other things the other 2 days of the week. But here you can see it, the instrument. And this was supported through a National Science Foundation grant that we got. So your tax dollars at work helped support this research. So this grant is just now ending. We're kind of in the final stages of that in report writing, and but you can see it glows. That's the cool thing about it. It glows. Okay, and that's the plasma. So this is something called plasma oxidation, and you can think of the sun is a plasma. That's a high temperature plasma. The better analogy would be a neon sign. A neon sign is like a low temperature plasma. And so this is running electricity through these copper electrodes through this glass tube, which is where your sample will go. And it creates electrically excited oxygen. Okay, and we'll talk more about that in a little bit, but this is exciting. We can do 10 samples in 2 days. I want to talk a little bit about paint samples and why we're using plasma oxidation. So the first thing we should think about is what is in a paint sample. And so, you know, you have pigment that causes the paint to have color. In the Lower Pecos, that would be iron ochres for reds and yellows. and a manganese oxide for black. And so that doesn't have any carbon in it, so I can't radiocarbon date that. That's just what gives the paint color. But these are really high quality paints that they're using. We see long brush strokes, very fluid paint over rough surfaces. And so we know that they were using binders and solvents and emulsifiers to make basically an oil-based paint like we would use. So this is the Lower Pecos artists were also good chemists, and they would process paint and make paint. And we know this because we find paint cakes in excavations, like where all the pigment has been powdered together and mixed with fat to make like a patty, like a cake of pigment. And they would have used water as their solvent, but we all know that fat and water don't mix. And so they would have needed to add an emulsifier to break down that fat and to make an oil, basically, to make a fluid paint. And they probably would have used the yucca plant for that. The yucca plant here would have been available. The root is sometimes called the soap root plant. And saponins are very much like soap molecules, and they break down the fat into something that can be fluid and makes a beautiful, beautiful paint. And so it's the plant material and the animal fat that we are going to be radiocarbon dating. So you've got your paint and they applied it to the wall. Now this is a very tiny little chip of paint turned on its side under magnification. And so you have the rock substrate, which is the wall, and then you have a black paint layer, and then you have a thin accretion, mineral accretion layer built up over time. And so a lot of times these paintings look kind of faded, but they're not faded. It's that you're having to look through that accretion layer. But we need a technique that can pull that animal fat and plant material out of that paint layer so that we can radiocarbon date it. Because we don't want to know the age of the rock, we want to know the age of the paint. And so we have to be able to pull that organic material out of that paint sample. So we use plasma oxidation. Now this is the instrument that we've had before where we only processed one sample at a time. And I show it just because it's simpler to see. So the sample would go in this glass tube with these copper electrodes on it. And then we fill this with oxygen and we turn on the electricity. This is connected to an RF generator and it creates this glow discharge, this where you see the light. What that does is that oxygen is reactive and it basically reacts with any organic material in your paint sample and converts it to carbon dioxide and water, breaks it down into carbon dioxide and water. And then that carbon dioxide and water travels through this tubing and it freezes in this glass tube here on the right, which is immersed in liquid nitrogen. So you freeze the water is water ice and you freeze the CO2 is dry ice inside this glass tube. And then you can seal that off and you have your carbon dioxide that just has carbon from the organic material in the paint. But your solid paint sample, your iron ochre, all of that stuff is still a solid over here in your sample chamber. So this is a way that plasma oxidation is used. It's why it's especially used to date rock art, because it's a way of pulling organic material out of samples that have a high mineral content. Okay, so just to kind of go over this a little bit, you know, we get a small sample, we pulverize it into a powder, we look at it under a microscope to make sure there's no rootlets or spider webs or anything like that in it, there's just the paint sample. We wash it with base because that's sort of a traditional way of processing radiocarbon samples. It has to do with removing any possible soil contaminants. Then we filter and dry it. Then we load the sample into the plasma instrument. We do something called an argon plasma. It's exactly the same as the oxygen plasma, except instead of oxygen gas, we use argon gas, which is inert. And so it doesn't do any reaction, but it just helps kind of make sure that there's no more trapped gases inside the chamber. And then we do an oxygen plasma. Finally, that's the goal, is to actually oxidize the sample. Okay. Then I use a blowtorch to seal off that tube that had the frozen carbon dioxide and water in it. And then that glass tube with that carbon dioxide gets sent to something called an accelerator mass spectrometry laboratory. And I know this is real technical, y'all just hang in there with me, but this is a instrument that it's pretty large, and it specifically does the radiocarbon measurement. It counts the number of carbon-14 atoms in the carbon sample that I send them. And so then from that, we can calculate age. I use, there's several of these laboratories in the US, but I have collaborated with Lawrence Livermore National Laboratory for about 20 years. So I still hang out with them. So, okay, but what are some other things that we do to know that we're getting the right age? Well, we also collect a control sample of unpainted rock. So right next to where the paint sample comes from, we take a sample of unpainted rock, and it goes through the same process in the laboratory that the paint sample does. And then we want to see how much organic contamination is in the rock. And of course, the goal is none. We don't want any in the rock. And so this idea is that if there's not any organic contamination in the rock, then we know that what we extracted from our paint sample is really from the paint sample and not from, something else that was there. So we want to make sure that that carbon is from the paint sample. So we do what we can to be real careful about that. Okay, so now let's talk about actual sites and some actual dates, some actual rock art. So this is Black Cave Annex, and we've got a new-ish radiocarbon date from it, in that it's this painting here. So you've got this beautiful anthropomorph with a horned serpent up above it, and you have it surrounded by impaled deer. So a small sample was analyzed from the deer, and we actually got something surprising. We got a younger age than anybody suspected. We got an age of 1465. This year's BP is a weird radiocarbon unit, and if so, I would have you guys kind of focus on this lower age, this 545 to 655 AD, calibrated AD. So this is regular calendar years here. Okay, so that's said. And so when we got this younger age, was like, well, maybe we need to look at this more carefully, because this didn't fall into the sort of 2,000 to 4,000 year old range that a lot of people had thought. We've been able, as we've gone to sites over the last few years, to collect a handful of samples. One of them was from this site. This is actually a site that had never been documented before. And the landowners actually contacted us about it, and we were able to get it documented. But it is, here's an enhanced image here. And it's got a lot of interesting things going on this panel. It's got sort of these human-like feline kind of, I would call them therianthropes. They're sort of half human, half animal figures that are facing each other with their arms out. And then there are these dots that are in between them. And then one of them has, it's what we call a power bundle. It's just sort of two lines with the ovoid shape coming off of it, off of its wrist. One of the cool things is that Carolyn Boyd has done some work and has some research that suggests that these dots represent sound and soul coming from the mouths of these figures. So I'm thinking that they're felines, they're making a big roar with the dots. We were also able to take a sample from this. Another thing that's interesting about these figures is they have black bands on their wrist, and we do see that as a repeated pattern on feline figures in the rock art. Oh, here we go. Here's this one. That's maybe better. Not quite so wild color enhancement. But they do have these black bands on their wrists. And oh, and I didn't say the age. Let me go back. It's 2,160 years ago, and I can't see the top because oh, here it is. It's 360 to 50 Cal BC. So that was the age that we got for these. So that was kind of pretty cool. And then another image that's not Pecos River style, but is most likely something called fold line geometric. It's a zigzag pattern here. This was dated to 400 to 205 BC. But what was really interesting about this is that there was a lot of fine line scratching associated with the painting. And so when you look at that up close, you can actually see that the paint infills the grooves, so that those grooves must have been there before the paint was applied, so that the grooves had to have been added sometime before the painting was made. So it's a minimum age of 205 BC, so that we know that those engraved grooves were produced no later than that. So that's kind of neat. So it's a minimum age for the engraving. Okay, a couple more. This is also at the same site, but it's a Pecos River style image with a U-shaped head, and it was from 1880 to 1650 BC. And so this is, again, we're able to get good dates that are on specific figures that we know the attributes. So this one has the U-shaped head, and it also has a power bundle. It has this lines with this ovoid shape associated with it. So then if we get more ages of that kind of figure, we can compare them in the future. I'm going to talk very briefly here about Eagle Cave. This is, to me, some of the most exciting work that we've done. It's about a 200 feet wide shelter, about 50 feet tall. And there have been excavations done at this site, but there is also rock art on the walls. The most known figure is this large, sort of 5 foot tall rabbit ear figure here. And you can see the person's hand, they're standing on the ground. So this is a pretty high up figure because they have their hand fully extended. And this figure also does have dots emanating from his mouth to represent sound or soul. And he has 2 rabbit ear figures, ears on his head. One's black outlined in red. The other one is yellow outlined in white. It's actually pretty hard to see. But we did take samples to the right of that figure. And we did something really cool here in that we dated not only the paint layer, but we also dated the accretion that was both over and underneath the paint. So we were able to get minimum and maximum ages for these samples. So that was really neat. That accretion layer is made out of both limestone, calcium carbonate, and something called calcium oxalate. That's that CaC2O4. That's the chemist in me. Oxalate, that carbon is from the air. So when that accretion formed, that carbon from the air is encapsulated into that accretion. And so we're able to get an age there. So here, we use some fancy techniques is all I'm going to say. We use something called X-ray diffraction to identify the minerals in these samples. This is at Texas A&M's laboratory. They let me use their toys. And we're able to identify the minerals that are in the samples. I also used another technique called Fourier transform infrared spectroscopy, which also tells me that the samples have the oxalate in them, because if we're going to date that oxalate, I need to know that it's present. So this is a chemistry thing to show me that those things are present. But we're able to use the plasma oxidation and the accelerator mass spectrometry to get these ages. And I really want to just show you a graph here, because lists of numbers are not easy to look at. But here in the blue are the 3 dates from paintings at Eagle Cave. And then you can see the orange and the green are the accretion dates that are both over and underneath the paint layers. So we got stratigraphic agreement between that. And the whole point of this is that you're using 2 different methods to date the rock art. It's just like when you go to the doctor and they tell you something, you might want a second opinion. So you go get a second test to make sure it's absolutely right. And that is our goal, is that we want to make sure that we're getting correct ages. And so we're using these 2 independent methods to do that. And so the rock art at Eagle Cave ranges, we're not going to talk today yet about how to read this graph, but it ranges from 1740 to 1420 BC. Also, what's really cool about this is that all three of the paintings at Eagle Cave are the same age, and it kind of shows what Carolyn Boyd has been showing with her research, and that these are compositions that were painted all at the same time. What I presented today, I hope there's some time for us to do some questions. I'm almost done. Is that I've been presenting some research that we have recently published. So this is a paper that came out this year on Eagle Cave, another one that came out in quaternary geochronology. Now, just to kind of talk about what's next, and that is that samples from new sites, and we want to the archaeology team's going to describe the figures. We're going to photograph them, even though they've probably already been photographed a gazillion times before. We're going to do it again. We're going to get illustrations, but we're going to do microscopy, which is field microscopy, where we look at the paint layering and all the superimpositioning on the mural. And then we're going to take from a central figure that we're interested in, and we're going to date that figure, but we're also going to date the things that that painting is in superimposition with, so we can compare the min and the max. And we may find out that all of it was painted at the same time, or we may be able to show, hey, this thing that has the paint layer closest to the air, furthest away from the wall, yeah, that really is younger. And so we're just getting extra data to show that we're getting correct ages. And so this is actually something that Carolyn Boyd and I proposed in a National Science Foundation grant. And I'm gonna let y'all in on a little secret. We just found out we got it. So, so we have another NSF grant coming to support this work. And so we're super excited to be able to get some more dates for Lower Pecos rock art. We're a team. This is a team effort, and I want to thank all of the Shumla archaeologists and wonderful people I get to collaborate with on a daily basis. And another thing is we have a new program. Some of you may know about it. It's called Shumla Treks, and Vicki Roberts is really leading this. And so some of you have been to the sites here, but some of you may not have and would like to go. And so we are doing these hiking trips to get more people aware of the rock art in the Lower Pecos. And so I know I ended up just talking and y'all didn't ask questions, because that's what I do. I taught college for too many years. But I'm going to stop sharing my screen in a minute so I can see your faces and you guys can ask me some questions. Okay, so in the chat. Okay, so the first question says, do you think the rock artists from one age copied art styles from much older rock art? Presumably the older art was there for them to see. Absolutely. There's some evidence to that, but the styles are very distinct. But I would say that you know, I don't know. On the I want to talk about red linear for a second because that's something I'm interested in. And that's the little stick figures that I said are always found underneath Pecos River style. I sort of have two hypotheses about them. That, you know, they were there long before the Pecos River style was there. And that what's really neat about it is sometimes it's as if the Pecos River style artist put them into their composition. So there's like the little stick figures, but they're like on the arm of the larger anthropomorph or something like that. And so that's just like one example where I think there was sort of incorporation of art that was already there. Of course, the other theory is that they were painted almost contemporaneously, but then they were still have been planned to do that kind of incorporation with both styles of art. So I don't know. That's why dating that art is so important for the little red linear figures, so that we'll know something about that. There was a gap of time between when those two styles were produced. But you do see sometimes historic art that has sort of more of a square body. And I think that's probably seeing some of the Pecos River style art that was already there. Let's see. I hope I answered that question. Y'all still good? Y'all, half of you, almost all of you are muted, so you have to like nod your heads. I'm gonna tell you what I used to tell my Zoom class, my high school students, like, you have to move your heads every once in a while to know that I know you're still awake. And okay, so what did the artist use to access the areas above body height? Any evidence of scaffolding found? I think that's the big question. We do know, I will say as a caveat, that some of these floor levels have changed over time. And so something now that is really high up might not have been quite as high up then. But then there are other sites where we know geologically the floor level has not changed and it's still like way up there. And there's, you know, we can't get to it without a ladder. So these ancient artists would have built ladders or scaffolding. We don't find any evidence of that in the excavations. I have a feeling, because this was ritual art, that stuff like that would have maybe been burned for a ritual reason, but also just a practical reason, because this is the desert and there's not a lot of resources around. And so if you have something you can burn for a fire, you're going to burn it. But that's just my take on that. Let's see, here's another one. Did a particular segment of society do the painting? Oh, that's a tough one, because, you know, we don't have the people here to ask them. But I think these are skilled artists. And I know in our society, there's people like me who appreciate art, but if I tried to make it, it wouldn't be as very good. I don't know about you guys, but I think these are people who are very skilled artists that were probably, you know, this is important stuff to their society. You know, they painted their walls with it, and it tells their myths and stories. And so I think this would have been something very important. I don't think it was everyone doing it, but that's just me. The eighth wonder of the world. Yes, Jade, it is pretty awesome. So how about any verbal questions out there? Anybody?
I have like a technical question about the new machine that you have going.
Yes.
So I see with like the sample chambers, it looks like there's all one line into this like to 10 like sample collection. Like how does each sample go into like each separate one, or are they all connected and they're just like reps of the same sample, or how does that work?
Okay, yeah, and I'm gonna share my screen again so y'all can see the instrument, and then I probably don't have as close up of a figure here, but I'll kind of go between two different pictures. So let me share again. And there it goes. Okay, so this is the one that's big, but it's kind of hard to see because it's in the dark and stuff. But do you see these sort of metal things that are sticking up here?
Yes.
So yeah, those are valves. And so what that does is it isolates each section from the next section. So you can close that open, you can close that off. So Jade, what we do is we load the samples into each of the sample chambers, which by the way, takes about 3 hours to load the samples into each chamber. And then, you pump all the air out, but then you fill this with, say, oxygen, okay? And then you close each one of these valves so that they are closed. So it's like having a single instrument just right next to another one, but they're isolated and separated from each other. And then you can kind of see hanging down from this, the glass tube. There's not a liquid nitrogen dewar on it, but that's where the liquid nitrogen dewar will go. I just don't have it. I've got pictures. I just forgot to put them in here, but there's, here's where that dewar will go. So you have 10 glass tubes also hanging down, which is where you'll collect that carbon dioxide. I know that probably made sense to Jade. I don't know how much it made sense to everyone else.
Very cool.
Yeah.
I found the use of the color, I would call it false color analysis, where you take the standard photo and modify the spectrum so that things that are indistinct stand out boldly. I thought that was really clever. Is that a common technique in rock art work?
Has become one, yes. So 20 years ago, people would have to take their photos and then go into Photoshop and try to do that themselves. But there's an app now called D-Stretch, and it uses something called decorrelation stretch, which they use for, like, NASA uses for modifying like colors in imagery, satellite imagery. But this is a specific app that was made by John Harmon, who was he's retired now, but he was a medical technology person that wrote computer programming for medical imaging. But he likes rock art, he studies rock art. And so he built this app specifically. It started out initially where he hacked Canon camera. You would put the program on your memory card and put it into your Canon camera, and then the buttons would do different things. But now it is on your iPhone or your Android phone, or you can put it on your computer. And it's been used in rock art, but a lot of people have also picked it up and started using it for other things. I've seen, it's still archaeology. I've seen archaeologists use it to pull out like soil profiles. I've seen people, it's still kind of rock art, like at Angkor Wat, a lot of that, some of that was painted, and so they can see paint remnants using that. But what it does is it kind of takes the color, and it's math that I don't understand, but it pulls it out into color space and makes it another color that we can see more easily.
I must go. Thank you so much for a wonderful session. Thank you.
You're welcome.
Do you still think that some of the panels were produced color by color rather than figure by figure?
We do. So the White Shaman site is the one that Carolyn Boyd studied the most, and it has probably about 300 digital field microscopy measurements that show that, where the black was painted first, then the red, then the yellow, and then the white. So these were this is for Pecos River style. These were murals that were painted all at the same time. We need to do that at more sites. And that's one of the things that we're going to do with this NSF grant, is we're going to do the digital microscopy in parallel and companion with the radiocarbon dating. And so we'll be able to pick the best samples that will help answer some of those questions. From our preliminary data that Shumla has, we know of about 6 portions of 6 other sites that have that color rule that occurs.
And one of them is the triad in Fay Bell, right?
It is.
Yeah. Okay.
Cool. Anything else? I hope y'all had a good lunch.
It was great.
Well, I'll ask a question. I'm not sure this is in the same subject, but are you continuing to do the LiDAR photography of these sites to try and preserve them digitally before the elements wash them away?
Yeah, so Shumla has been for the past 4 years doing a particular documentation. We've been here for Shumla has. I've only been here for 4.5 years, but Shumla has been here for over 20 years documenting the rock art. And excuse me. And in the last 4 years, we went to as many sites as we could humanly possibly go to. And they went to, I can't remember the grand total, but I think it was like 284 sites or something like that. And part of the process is each site is that they did photogrammetry. LiDAR, we can't afford to LiDAR. One site costs about, I think, $20,000 or $30,000.
Wow.
So what we do is we do poor man's LiDAR, which is photogrammetry, which is where you take overlapping photographs and then you use a supercomputer to stitch those together to create a 3D model. To be honest, in some ways it's better than LiDAR because you get, LiDAR, you only get the shape of the wall. You still have to put photographs meshed onto that shape. So with the photogrammetry, we're actually able to create digital 3D models of these sites to sort of preserve them so that they're at least digitally preserved. And that was done for over, I would say about 280. I don't remember the final number, but and we're using that data to figure out what's the best site to go to for our future research, because we don't have to hike out there every time we want to go look at it. We can pull it up on our computer and look at it.
Yeah, and share it with other people too, other experts.
Yeah, and it's on, a lot of those sites are publicly available on Sketchfab. So, and it's on our website. There's a link on our website.
Yeah, I think it's great work you're doing.
Thank you. And if you're on mute, I saw your hand and you started to talk.
Now better?
Yes.
Oh, I'm just generally, is there any collaboration or is there even possible to do so with any rock art sites on the other side of the border? It always has intrigued me, and I know that there are sites, and of course everything is difficult now, but that would be an interesting avenue, I would imagine.
So right now we have a postdoctoral researcher named Diana Rolon, Doctora Diana Rolon, and she's from Mexico City. And she is here in Comstock at Shumla right now for this year. She's a postdoctoral researcher with Carolyn at Texas State, but she's working here. And our dream is that, you know, she's learning all of our documentation techniques here, and we want her to work on this side of the border, but we also want her to work on the other side of the border and do that. And so we're really making some headway, I think, with that, with the collaborations we have with Mexican researchers. And so I'm really excited about that. I'm really excited that we have her here.
Me too.
It's hard to go there.
Everything has been hard.
Yeah, if I could just swim across the river and go to the site, it would be easy,
Yes.
but I can't do that. So
No. Oh, better days ahead.
yes, this was really fun for me. I mean, never asked a researcher to talk about their research. I mean, I could have gone on for 3 more hours, but I didn't want to do that to you guys.
We'll hope to come out and pester you in person one day when things get better.
Wonderful.
Looks like we're out of questions, Karen.
Okay, yeah, I think so. So I just say thank you all for listening, and thanks for tuning in.